Good afternoon, everyone. My name is Christine Hammond. I'm with the American Institute of Architects, Long Beach South Bay chapter. I'm here with Diana Esquire, if hopefully I'm saying her.
Close enough. Diana Esquire. Hi, good morning or good afternoon, everybody.
Thanks, Diana. She's with the Pasadena Foothill office or chapter rather, and we are here for the webinar with PPM, and I'm going to introduce Cameron Slatterbeck and Greg Davies. And Cameron has been with PPM for over 13 years, and Greg has been with PPM since 2013. So I'll hand it over to them. And just before I do that, I've placed in the chat a link, which all attendees should use the link to record their attendance. And you can also use this QR code that's on the screen with your cell phone. If you're sitting in front of your computer at lunchtime, pick up your cell phone and scan the QR code, or use the link in the chat to record your attendance. You must use that link in order to receive AIA credits. And if you need a certificate of completion, if you are not an AIA member, but you need that for work or for any other type of certification that you hold, just message me in the chat, or Diana, if you're from Pasadena Foothill, and we'll make sure that you get to that. So without further ado, I am going to hand it over to Cameron.
Yeah, thank you, Christine. Are we seeing the presentation properly? Yes. Just to confirm? Okay, cool.
Okay.
Well, thank you, Christine. Rest of the AIA Long Beach South Bay chapter, of course, for having us, and also welcome Diana and members of the Pasadena Foothill chapter. Happy to have you guys. Thanks for joining us. Definitely really excited today to be teaching what we call best practices for as-built surveying, drafting, and modeling. So let's get started here. So as Christine mentioned, I'm Cameron Slatterbeck. I've been with PPM for something like 13 years. I'm the regional director for our SoCal region here at Precision Property Measurements. I will start off the first portion of this presentation and then piggyback toward the back end. But we'll also be hearing from Greg Davies, who also been here for many years at PPM, and he is our director of special operations for our national team at Precision Property Measurements. So we'll hear from him in a bit. So a quick course description. So this class is a demonstration of how to procure a proper set of as-built plans when needed for any structure. It'll briefly cover the reasons they're needed, technique in obtaining information on site, including 3D laser scanning and traditional methods, and finally, the drafting in CAD or modeling in Revit to suit your design needs. Some learning objectives here. End of the course, participants should be able to, one, begin a project by determining if as-builts are needed, understand the scope of work from an as-built only perspective and how that'll achieve different goals, to give you a head start on creating design elements, construction documents, and obtaining those permits. Two, obtain as-built plans for all levels of scope through some traditional but also very fundamental methods. Three, understanding new methods for gathering that data on site, such as LiDAR scanning and 3D photogrammetry, which Greg will be talking mostly about. And then finally, four, putting down that collected data into both AutoCAD and Revit. And so we'll be doing this in 4 sections. And so the first section is going to be, what are as-built plans? So we'll go over some common definitions, when as-builts are in fact needed, gathering various degrees of information when, and I'm talking about when projects require a detailed scope. Second, traditional, we'll be going through traditional surveying methods, vis-a-vis sketching, plan view measurements, the Z-axis, stuff like that. Then we'll go into laser scanning, the new era, which we call it. So Greg will be touching on terrestrial scanners, mobile scanners, point clouds, using that point cloud data. And then finally, chapter 4, which will be creating an as-built set. So drafting that data from the traditional method, also drafting and modeling from the point cloud. So quickly also wanted to mention that throughout the presentation, we're going to have a series of polls in which I'll ask you all a multiple choice question. We'll also have a Q&A section at the end of the presentation, so please do hold all your questions till then. We'll open it for questions at the end should you have any questions for us. So starting off with chapter 1. So what are as-built plans? Some common definitions. So when looking into the actual definition of as-built plans, what one will most likely find is a definition that concerns as-built plans being created after or during new construction or after or during a renovation. So they're prepared by the contractor. They potentially use red ink to show on-site changes to the original construction documents. And they're more like interpolations done for construction purposes. Therefore, the changes that the contractor makes onto the original design are called as-built drawings. And then we have record drawings. So contractor developed as-builts should not be confused with record drawings created, of course, by you, the architect or engineer. So record or archive drawings are often, they include the information gathered on as-builts and are the final set of formally developed prints, fully signed and stamped by the project engineer. So this definition kind of more reads, of course, they're prepared by the architect or engineer, like I mentioned. They reflect on-site changes the contractor noted in the as-built drawings, and they're often compiled as a set of on-site changes made for the owner per the owner architect contract. And this set isn't always mandatory. It's not mandatorily or created necessarily, but in general, some formal architectural services create these as one of the last tasks of a building project. And so here we are, first poll of the day already. So I wanted to ask you guys, how many times has a contractor you've worked with actually created as-builts for you as we described in that last slide? So A, never, B, sometimes, or C, always. And if you could put some of your answers in the chat, we'll take a quick look at that. But I imagine we're going to see some common answers closer to the never or sometimes
We're
realm.
seeing mostly nevers so far. Getting some sometimes is in now, but more nevers.
I see that. I definitely see that there's never any always answers. Definitely don't see any of those, which is good. We'll go over that in this presentation. Well, thanks for chiming in the chat. We'll have some more polls and keep those answers coming. So what is an as-built plan? So let's keep it simple. I think we can all agree that simply put, in the architecture and construction industry, as-built refers to a drawing that shows the existing dimensions and conditions of a building, space, or area. And so before we get any further, I want to say that throughout the presentation, we'll be discussing producing as-built plans in their final format as either a 3D Revit model or a 2D CAD file. And both are types of software created by Autodesk. As you likely all know, there's many other types of drafting and modeling software out there. So even though I mentioned Autodesk software, it's likely you can apply most of these points, if not all, that we make about 2D drafting software to all others in the market, as well as those other types of 3D modeling software. So when are as-builts needed? What are the contributing factors when as-builts are needed? So pretty much whenever we're working with an existing building, we need as-builts before starting design. Also, when existing plans are determined to be unreliable, you'll probably need as-builts. Also, when there are no existing plans. And then finally, maybe if you work in a particular software and existing plans only exist in paper format. If the owner or client happens to already have as-built drawings, then we may just need to enter those into CAD or reformat them if they're already in CAD and confirm that the drawings are up to date. If errors or consistencies are found, which we've found is quite often, then at some point you may just decide that a fresh set of as-builts is needed. And now, when aren't as-builts needed? It is rare that clients already have current as-builts of their existing building that are accurate, as I mentioned before, but it does happen. And so in that case, of course, you would not need more before starting your project, of course. There are also simple cosmetic projects that don't require having accurate as-built plans. And of course, if your building is being built from scratch, then all you need are those new construction documents. And so when is the best time to obtain as-built plans? In most cases, obtaining as-built files is one of the very first steps in the renovation process, if not the very first step. Getting ahead of this step allows an architect to focus on the design, plan creation, and submittal to the building department, all of which are considerably more time-consuming than that first step. There's also cases where you'll be working maybe with the historical review or something like that, and they'll require as-builts are to be created. Most engineers will want a fresh and accurate set of as-builts before they begin say a seismic retrofit project. So if you're working on a teardown project as well, some building departments even require you submit as-built plans of the structures that are being demoed. And so some other contributing factors as well, as mentioned on the previous slide, different municipalities work differently and have different requirements. If they require as-builts for any reason, the type or the scope needed may vary from city to city. If you plan to preserve or improve upon detailed architectural elements such as ornamentation, you'll need to consider that documentation and where it fits in your timeline. Overall, the size and scope of your project will determine when as-builts are needed. And as we'll discuss in the next section, to what degree the detail and scope of as-builts are required. And so you've discovered that as-builts are needed. You're going to need those as-builts. So how far or in how much detail do you now need those as-builts or that information to go on those as-builts? So above are a few examples of plan types and when they're needed in your as-built plan set. So you might need floor plans. You almost always will need that as a base plan to work from. You might need exterior elevations when the work impacts the exterior facades of the building or structure. Sections, also a common one when you're working with height constraints or vertical relationships between spaces. And then finally, one of the more common plan types that comes across is reflected ceiling plans as well. So when you're modifying the existing lighting or working with unique ceilings, that's definitely common. Ultimately, it's up to you as the architect to decide what the scope should be for your as-built plan set, or consult with your engineer as well on what is needed. So before we get into specifics regarding plan types, let's go over some of the ways to gather on-site information, starting with a very simple, quick method, and then ending with full-blown as-built plans. So now we know what we need. We know why we need it. Now, how do we actually get it? So first potential step would just be getting photos only. One way to obtain the answers you need on site before renovation is by simply just taking those photos. This can assist in design process and answer questions you might have before proceeding. Next up would maybe be a single line diagram. So sometimes a quick single line or even maybe a bubble diagram is all you need to achieve your goals. This can be achieved quite quickly on site and doesn't necessarily even need to be to scale. Beyond that would be sketching. So sketching can be very helpful in supporting your design. In the case of interior elevations or perspectives, this can also be done roughly and may not require measurement. And then finally, measuring. So if drawings need to be to scale, such as when they'll be used to create construction documents, then you'll need to go to a higher level of accuracy and measure the existing conditions entirely. How you get these measurements can vary quite a bit, as you'll see throughout this presentation. So most remodel projects require a more detailed scope for as-built. So this will give you a head start in the creation of your design, submittal, and construction documents. So to sum up the first portion of the presentation, chapter 1, understanding as-built plans. As-built plans, simply defined, is a set of plans of any structure as it exists at that moment. They're most often used for a renovation of some type. Also, getting as-built drawings in the format in which you work is incredibly important, such as a particular software. And then finally, the scope of the as-built plans and the detail of each scope item will vary with the needs of your project. And so now let's jump into chapter 2, which is going to be touching on traditional surveying methods. We'll talk about an as-built production method that's near and dear to many of our hearts here at PPM. This is how we started 20 some odd years ago, and that is sketching. So here's how you might sketch. Remember that sketching does not need to be to scale. All you need to do is make sure that there is room to write all the measurements you need, and that it is visually easy enough to follow back in the office. So using different colors to mark different measurements and drawing types is helpful, so that your eye will catch each segment accordingly when you're drafting, and you don't spend as much time kind of hunting around the sketch for what you need at that moment. Getting as much sketching done as you can before measuring is highly recommended, so you can just focus on measurements when the time comes and simply execute that. The better your sketching is, the easier your measurement will be. If sketched correctly, any structure could be measured much quicker. Leave room to write in measurements. That's a big one. So plan ahead also to get your heights or measurements on the Z-axis. Most of the time, this information can still be displayed in plan view, but occasionally you'll want to sketch in section or elevation view as well. We'll talk about that again in the next few slides. And finally, sketch out any details or ornamentation to the degree of precision you desire to be able to add measurements later on. So now it's time to add measurements to your sketch. So an important step that many people skip when measuring a structure is going around the exterior faces. We find this incredibly crucial. Oftentimes, a wall thickness at an exterior wall is taken and then simply moving right onto the interior and taking those interior measurements from there. But we consider, like I said, this exterior footprint measurement to be extremely crucial. And a quick tip with this, as you see on this sketch here on the bottom right corner, check your work, add up all the X values and all of the Y values. And if you sum up, all the X values on each side of the building, if those add up to the same number, at least very close, then you're on the right track. As you see, that says 560 versus 562, and then simply do that same for the Y values as well. And now in this sketch, you may notice that there are some overall measurements as well as small incremental measurements. This is a good system of checks and balances that'll not only improve overall accuracy, it may save you in the event you have an incorrect measurement or notation. Don't forget to get good photo coverage as well. That'll help you verify that what you are drafting is indeed correct. Occasionally, it happens. We've seen errors that do happen or appear as errors or don't appear as errors on paper, but then become very obvious when you fact check that or verify that with a photo. So as you can see, this image shows the previous sketch, but with a sheet of vellum over it. This allows us to use the information from the first sketch, such as wall layout, and add even more symbols and measurements above that, and not necessarily need to resketch all the walls, doors, etc. that you previously did on that previous sketch. This can be super helpful if you need to add items and you're out of room on that previous sketch and need to write those down. Or it's also useful when you're adding detail items like electrical faceplates, cabinetry, RCP, things like that. So the Z-axis, now we can talk about collecting those height measurements or height information using traditional methods. So this one's pretty obvious. You can use a tape measure to measure all the risers and the stairs, drop it down a balcony, run it up a wall, etc. We've all used that. A laser distance meter or disto can perform trigonometric functions instantly and get you heights in all sorts of ways. These first two, of course, are tools that you might already be using to measure all other aspects of your plans. But the third is used exclusively to gather height information, and that is the zip level. So this is an excellent tool, invented, distributed, repaired, if needed, by a company out in San Diego. I'm actually not even aware of any other version of this tool, but it basically uses displacement to read heights anywhere within a 50-foot radius. Super helpful when you're getting that height Z-axis information. So however you collected your height measurements, make sure you got them in the places that you'll need them. Most of the areas will be obvious, like the tops of any steps, staircases, floor transitions, things like that. Plan on what you'll need to see in those exterior elevation and section views. Make sure you have either some basic height and good pitch information from your roof or for your roof, or if it's safe to actually get up on the roof, gather as many height information measurements as possible while you're up there. Make sure to not forget the heights of openings such as windows in areas you plan to show, or the heights of items like wall sconces if you plan to produce detailed interior elevations. And so to sum up the second portion, traditional surveying method, overall, having the perfect sketch isn't even all that important. What you need is a sketch that displays and contains all the measurements you'll need for the drafting phase. You need to encapsulate the structure by measuring around it. This will give you the scale when you begin drafting and ensure your interior measurements are correct as well. And then finally, after taking the measurement of more major items like walls, doors, and windows, go ahead and move on to the next level of detail as needed. So this can be for cabinetry, plumbing fixtures, electrical, ceiling components, etc. And so here we are with our second poll, and I'll pull up the chat here as well. But my question is, how comfortable are you with sketching and measuring as-builts? So we have option A, very uncomfortable. It makes me sweat just to think about it. Might see some answers there for A, but we have B, I've done it, but I don't necessarily like it. C, I'm comfortable doing this. And then finally, D, I always sketch and measure my as-builts, and I absolutely love doing it. So let's see. We might see some variation in the answers on this one, I would imagine.
Ooh, I'm seeing so far all C's. I've never seen this many C's in one of these before.
Yeah.
Cameron. We have a very comfortable, we have a very comfortable crowd here.
Yeah, you're right. That's typically, I feel like we get A's and B's for the most part, but good to see everyone's comfortable doing this already. B/C. Probably right in that, yeah. Well, thank you guys. Appreciate your feedback there. And then let's see, competent. I like that. That's the best answer in the chat. Good one, Winston. So now I will kick this over to chapter 3, kick it to Greg, who will be going over laser scanning. Take it away.
Yeah, thanks, Cam. Yeah, I love watching that segment of the class. It just brings me back to the good old days of using that old school method to get all my plans. And as much as I do miss those days sometimes, that was always a good puzzle to figure out. I am looking forward to talking about laser scanners and LiDAR and point clouds together as built survey data, because Lord knows they've made my life quite a bit easier. So updating or even replacing a proven method for doing something to utilize the newest technology is not easy, and that's no matter what industry you're in. The first step you take is always the most important, and the rest is just hard work and diligence from there. Even though it may be difficult to transition, as we found, making the change to laser scanning as a survey method provides you with fast acquisition of as-built data using 3D laser scanners, more accurate measurements than they can be taken by hand, primarily just by reducing the odds of human error in the field. Technology can be purchased, rented, or even contracted as a service. It's a thorough solution that allows you to gather more data than needed to complete the drawings and models. And it provides you, even after you finish the drafting, with a digital twin of any property that allows you to essentially visit the site from the comfort of your office and pull up additional data just if the scope of the project changes or you need additional info. So here are some examples of each type of laser scanner. So on the left, we have terrestrial or stationary, and on the right, we have mobile, and these scanners can be moved while the scanning takes place. So the terrestrial scanner, that sits on a tripod, it spins to gather the 3D data from one position. And after scanning hundreds of individual positions with good overlap between all of them, you can bring all of the data into one big data set for your project. Now, the mobile scanner allows you to get a similar end result. It gives you that full 3D picture, but by utilizing an algorithm called SLAM, which stands for simultaneous localization and mapping, the scanner and the accompanying software allow you to gather the 3D data while simply walking through a space. As you can imagine, this dramatically reduces the amount of time to capture the data in the field. So I don't know if any of you have heard of LiDAR before. I'm sure you've heard of laser scanners, but all laser scanners run on something called LiDAR technology, which stands for light detection and ranging. LiDAR is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. And each one of those illuminations is considered a measurement, a very accurate measurement. So as each single measurement is logged throughout the course of the scan, millions of measurements are taken in all directions, which then creates what we call a point cloud. So first, let's talk a little bit more about a terrestrial scanner that that we have used in the field. It's not our standard, but it's something that we've used in the past. And then we'll talk about our preferred scanner. So this is the Faro Focus. It is a stationary or terrestrial scanner. It captures about 1 million points per second. It has super high color resolution, up to 266 megapixels, and it's extremely precise, plus or minus a millimeter. So that's any individual measurement that you find is going to be accurate to plus or minus, around a 1/16 of an inch or less. And then moving on to the RTC and the handsome fellow pictured there operating it. Also a stationary scanner, but this one gathers about 2 million points per second. It has a higher resolution. The precision is a little bit less, but still extremely accurate for our as-built standards. The reason that I prefer this scanner is it's just so much faster than any of the other terrestrial scanners on the market. Because it's gathering those 2 million points per second, it allows a scan to finish much more quickly while still getting the same density of data. And we use this for tracking all kinds of information and very precise MEP information, conduit runs, things like that. And then this is an example of the point cloud output from the Leica RTC 360. This was a survey done of the Easy Street Casino in let's see, what is it? Century City, Colorado, I think is what it's called. The gambling town in Colorado. And as you can see, you can navigate through this 3D space by clicking on the different positions that the scans were taken from. And even though there were no photos taken during the scan, you can see that you have very photorealistic information in this scan, which is extremely helpful when producing detailed as-builts, because it helps us really see and get the context of where we're at within the data. So those terrestrial scanners, they make great looking data, but I'd also like to talk about the scanners that we're most familiar here with here at PPM, and those are the mobile scanners. So the mobile GeoSlam Zeb Revo, the trade-off for a less colorful point cloud or a hyper level of position is that with a mobile scanner, you greatly reduce the amount of time that you spend on site taking measurements, because scanning is done continuously while walking through a space and does not need to be mounted on a tripod. Even stacked up against the Leica scanner we just discussed, 3 hours of scanning can be cut down to 15 minutes with a mobile scanner like this one. These scanners are also very modular. You can mount them to other equipment to them, like a GoPro camera, or you can even mount the scanner itself to a drone. This is a newer model from Leica called the BLK to Go. Between this scanner and the scanner we just looked at from GeoSlam, there are some pros and cons. For example, this produces a much more photorealistic colored point cloud, but the level of precision is a little less finite. So in the next slide, we'll see a short video of a scan taken with a Zeb Revo. That was the first one from GeoSlam that's mobile that we looked at. This one is taken of a large residential property, and you can see that even though there is no photo-based colorization of the points, these points are colored on what's called a height ramp, where points at different heights are shown as different colors on a spectrum, which you can see on the left. Red is a lower height, blue is a higher height. So coloring the points this way makes it easier to see important features in the point cloud, even without that photo colorization. Okay, so to wrap up using mobile scanners in the field, using a mobile scanner is preferable if your time on site is limited, which it almost always is. Once the scan is complete, you need to use the SLAM algorithm software, which interprets all the measurement and movement data from the scanner and produces the 3D point cloud. Since most individual scans take only 15 to 45 minutes, this will give you time to process the scan on site to check all of your results before you leave. Reviewing your point cloud on site is essential to ensure accuracy. Most errors in scanning or processing can be spotted quickly, and actions can be taken to ensure the overall accuracy of your project when the time comes to draft your model. All right, so we've talked a lot about this point cloud, but let's talk a little bit more about what it is and what to look out for before bringing it into your favorite CAD or BIM software. So reviewing your data very well before attempting to create a set of as-builts from a point cloud is an absolute must. If there are any kinds of errors with your cloud, which do happen, then using the bad data can either stop you in your tracks when you're drafting or modeling, or even worse, result in an incorrect set of as-builts. So once your scan is processed, you'll need to review the output. You want to check to see if you covered all your areas. Did you miss any closets or any bedrooms or any areas at all? And then you want to look for flaws or errors in the data. Sometimes you see some ghosting and something that we call drifting, which we'll take a look at a few examples of here. So here's a great example of some pretty massive drift. And this can occur when the software has trouble putting all of those individual measurement points together. So if this occurs, then you can try some reprocessing options or simply scan the structure again. Determining the reason for the error is crucial to informing your decision on how best to reprocess your scan, your point cloud, or rescanning your project. Now that said, here are some other examples of drifting. So in this case, we're looking at a bathroom, and the bathtub on the left is incorrectly showing itself to be in the kitchen area. So unless they designed this house to have a bathtub in the kitchen, we're pretty sure that that's not actually accurate data. Also, the vanity on the right side isn't in line with where it should have been. So you can see those red arrows indicating that there. And the error on the right is clear due to that empty or dark space. And even though plumbing walls are usually a little bit wider, they're usually not that wide compared to the rest of your walls. Now, this is another more unique example of drifting, and we've been seeing that this perhaps indicates an issue with the scanner itself. But heavy drifting that kind of rotates a space within what clearly should be a basic rectangular room is an indication that yeah, something might be wrong with your scanner, or something just might be wrong with the way that the project was scanned. And then the last example of drifting, even small amounts of drift can make it difficult to place walls precisely. Here you can see that there's some duplicate lines around where the walls should be, and it makes it near impossible to discern where exactly those lines should be placed when you're doing your drafting. So some scanners are better than others at different types of projects. There's a tool for every job, but all scanners can run into some challenges in creating good point cloud data in certain field conditions. So one of those conditions is changing heights. So when scanning attics, foundations, large sites, or multi-level structures, you may run into issues getting your vertical data to all fit together. Usually because in order to relate one set of data from one floor to another, you have to go through a very small spot to do it. So you just run out of as many significant features to help stitch everything together. Also, areas that are hard to access, that have lots of reflective surfaces, those can also create a lot of issues. Big open areas like the one pictured here with repetitive features can sometimes cause some troubles, and you've got to scan carefully to make sure you get that accurate. So most scanners have a range of hundreds of feet, and this can produce a lot of data outside of your project that you don't need. You may need to clip or crop your point cloud to reduce the overall file size that you generate by getting rid of this unwanted data. If you have to produce multiple point clouds for a large or complex project, it will be important to get comfortable with point cloud software that will allow you to merge or register your clouds and manage your data more easily. So much like the traditional method of sketching and measuring, properly scanning a structure takes a lot of practice to do correctly and efficiently. But once you are practiced with scanning and know what to look for and where errors may have occurred, you will have the most reliable version of data that you can gather in the field. You can be confident that the as-built plans you create will be fully accurate and ensure a smooth and safe renovation as it progresses. Okay, so you've gone out in the field, you took your fancy laser scanner out there and you have a point cloud, but now what do you do with it? So now that you've processed and reviewed all of the point cloud data, you'll need to do one of the two following things. One, do it all over again if it came out poorly, or two, bring your point cloud into your drafting modeling station to get started with the next phase. So from there, as you can see in the pictures, you want to cut slices of your data, view it from all directions to start looking at how to produce your plans. And in order to produce them, or in addition to cutting these slices, you'll want to be able to move and rotate the clouds to get any viewer perspective you need on the property to be able to perform your work. While there certainly is a learning curve, any CAD or BIM software that supports point clouds can do this for you easily. So we're going to get into creating the as-built set in our next section here, but I have some slides that can display just how you can get acclimated with the point cloud with the photos you've taken on site. Here you can see a 360 photo on the left, which allows you to pan around it within 360 degrees. If it was safe enough to get up on the roof with the scanner, then you're in luck and you'll have some excellent data to work with in your drafting and particularly your modeling. It's always good to have photos open while you do this, regardless, to ensure that it's correct. Scan data from inside an attic can also be very useful in displaying the behavior of a roof. And here, there's always opportunities for point cloud data to fool you. Here, it's not clear which way this door actually swings into the laundry room. So a photo seals the deal. So looking in section view in the point cloud throughout the project, or even before you start your work, is always a good idea. You'll be seeing the structure in a way that you can't really see it in person, unless you happen to have the biggest chainsaw ever and permission to use it to cut through the home. Having this point cloud data is extremely beneficial over measuring with traditional methods when sections need to be created for the plan set as well. All right, so in summary on the 3D laser scanning, first, scanning your project will prevent costly revisits to site due to errors and will reduce your time spent on site. The type of scanner you use will be dictated by your needs and level of detail required. And your scanner will create a cloud made up of millions of points. Knowing how to manipulate the point cloud in your preferred drafting and modeling software is crucial to using your surveyor data. As an added note, while LiDAR has been around for about 20 years, more and more as-built surveys of all types are shifting away from the traditional methods to using the latest in laser technology. As with every new production method, there's always a learning curve, but once mastered, the entire process gets much smoother. When incorporated with BIM technologies, the entire construction process can get a boost in speed, efficiency, and have a lesser environmental impact. So that's it from me for now. Back to you, Cameron.
Yeah, thank you, Greg. Appreciate it. So on to the last chapter. So creating an as-built plan set. So now that you've collected the measurements in the field, it's time to create that actual plan set. It's important to keep these organized and concise, but at the same time, leave room for notes, building code information, etc., just so they can be used down the line for design layouts, demo plans, construction documents, things like that, as we did discuss earlier. And so Greg just talked about, recently about scanning. So now we have to shift gears back to the traditional method that I was speaking about earlier on how to translate those sketches into great as-built plans. So drafting from sketches, prop your sketch next to your computer and just fire away. It's a pretty straightforward process. Use a vector-based drawing software and draft to full scale, entering actual measurements from your on-site sketch. If you are modeling in Revit from a sketch, it's more difficult, but it's not impossible. In this case, you're more building rather than drawing. So you'll often find that you'll need to let the model dictate certain measurements and kind of override the ones that you took on the site. So for a floor plan, you're going to be primarily using that line tool in combination with whatever blocks you've created. The perimeter line usually comes first, as it does in the field when you're measuring. So starting with interior plan types, you want to draft your walls first, then go on to windows and doors. If there are multiple levels, you'll not only need to draft using your measurements, but also be very, very cognizant of those stairwell walls and exterior faces of the structure, just to make sure that they are lining up exactly as they very likely do in real life. So once those controlling items are done, you can draft in with perhaps a lesser degree of precision, but cabinetry, plumbing fixtures, appliances, etc. For an electrical and RCP, it's much the same. Follow what you've sketched and measured and add the items one by one. So you'll need for roof elevation and section plan types, you'll need to at least have sketched the behavior of the roof correctly in the field, or by using nice clear satellite photo at the very least. This means all the hips, valleys, ridges, and the direction of any slopes. This and the measured length of all overhangs should get you to a place where you can draft the roof in plan view. On the same roof sketch, you'll need to have also collected all the height information. So this is often achieved by using a zip level, which I mentioned a bit ago, and getting on the roof to take all necessary height readings. That said, there are other methods such as using an angle finder, level, using various functions of a disto laser as well can get you that information. So drafting elevations will come entirely from your floor plan and roof plan sketches. So the only exception maybe is special sketches where you'll show certain aspects of ornamentation or things like that on the exterior. But drafting elevations will entail placing all windows and doors correctly with correct heights. And of course, it's important to ensure that they correspond directly with the floor plans in those cases. Any decorative items that you sketched and measured can be drafted as well at this point. Drafting a roof and elevation view is one of the most difficult challenges in drafting an as-built plan set. And so it needs to correspond perfectly in all those other elevation views. So when we're talking about sections here, so once the cut location and direction are determined, you'll use that floor and ceiling information that you sketched and measured on site to complete the section view. So to draft the roof properly in section view, it's highly, highly advised to have your elevation drawings already finished in order to use that same exact information to complete your section drawings. And now I will kick this right back to Greg, and he'll talk about drafting from the point cloud. Take it away.
Awesome. Thanks, Cam. And yeah, drafting from the point cloud, very similar to doing the drafting from sketches, except instead of inputting all of those dimensions from the sketch, you have the point cloud to work from. So let's take a trip back to the laser scanning survey method and talk about doing this with the point cloud. So when drafting from a point cloud, the first thing you'll need to do is get it into the drawing environment. Point clouds can be imported directly into AutoCAD or Revit, as well as other architectural software. One note on that, though, if you're using Autodesk products, you'll need to use an application called Recap to prepare the point cloud to ensure it works with their entire software suite. Other softwares can pretty much just take just about any format of point cloud. But Autodesk has to be special. So drafting from a point cloud in CAD is mostly straightforward. It does take some getting used to. But ultimately, point clouds are ideal as-built data sets for creating Revit models. But the Revit point cloud tools can feel a bit lacking compared to the AutoCAD tools. All right. So first, we can talk about drafting the plan view items from a cloud. When drafting in CAD from a point cloud, you'll want to ensure that your cloud is positioned orthogonally so that you can use the ortho function in CAD to very easily draw the lines. You'll also want to make sure that your cloud is on the Z-axis in CAD. That's desirable for several reasons. You should be able to derive all the walls, doors, and door swings right from the point cloud. Window information can be found as well when you are skilled at reviewing point clouds. Many scanners will not pick up the smaller items, especially if they are flush with the walls or ceiling. So trying to locate them in the cloud can be very time consuming in that case. So it's often better to revert to the traditional method in the field to just sketch and measure those items, light switches, outlets, things like that. So now let's get into drafting other views, such as an elevation from the cloud. This is where there's a huge advantage in having a complete point cloud for drafting. Provided that you are able to access the roof in scanning, you will have a complete picture of not only the roof behavior, but also every height that you'll need to properly draft your roof, your exterior elevations, and any section you might need. As with electrical and RCP components, sometimes it's beneficial to revert to that traditional method to sketch ornamental items that you'd like to include in your drafting. So as I mentioned, while point clouds can definitely be used to easily draw 2D plans once you get a nice slice of that data, where they really shine is in creating a 3D Revit model. Since Revit is an extremely powerful tool that can store information on every assembly within a given structure, the level of development system was created for the AEC community to describe different levels of BIM models and the uses for each level. So this set of standards gets into the precision, construction detail, and overall refinement of each set of objects in your model. On the simplest end, we have LOD 100, and that's just a single solid 3D mass of an object or even of an entire property, often used for like city planning and civil reasons. Level 500 is on the most complex end, and it's so thorough that the model of the building is essentially a virtual version of the entire structure: nuts, bolts, bolt threads, bolt diameters, bolt lengths, washers, and all. So in modeling and as-built plans, somewhere between LOD 200 and 300 are the most practical levels for a light and usable Revit model. And even though laser scanners gather a lot of data, you're still assessing a structure from the outside. All of the interstitial spaces are inaccessible, and their construction cannot be assumed. For example, an LOD 200 electrical plan in Revit will look a lot like a 2D electrical plan in CAD, even though the rest of the architectural model is in 3D. However, in LOD 300, electrical items and other structural elements are fully realized in the 3D Revit model along with the rest of the architectural model. So Revit has many tools to build site plans and topography if needed. If you only plan to model as-built to the structure, you may want to limit your site work to the areas that surround or touch the structure only, if at all. In the case of exterior elevations like this one, the point cloud will make it easy to make sure that the finished grade is accurate along the face of the house. This can be achieved without going into all of Revit's topography tools, and can be done using some simple masking and model line tools that help to hide unsightly Revit artifacts that you may not want to see in a clean elevation. So similar to drafting in AutoCAD, the first thing you need to do to work with a point cloud in Revit is to make sure it is in the recap project format for use with all of the Autodesk products. Using the point cloud to guide modeling in 3D can be more complex than drafting in 2D. However, the benefits of having all elements of a building related to each other in 3D can be extremely valuable to your design and planning process, as seen here in this power plant in Oakland. All of the ways in which the 3D elements interact with each other, you just can't see that in a set of standard 2D plans. Viewing the point cloud and model in 3D, it provides a lot more information about how structure, MEP systems, and architecture all interact. And then modeling and as-built in Revit, it may seem overwhelming at first, but a solid order of operations for creating a usable Revit model will go a long way. So a little bit about that. Point cloud setup is extremely important. You want to rotate the cloud in plan view so walls are easy to place orthogonally, just like in CAD. It's important to set this orthogonally to create a usable Revit model, as Revit is not a huge fan of having walls set to 89.9 degrees. Then you want to make sure you set the desired finished floor of the point cloud to your 0, 0 level in Revit. Then set all other levels to key features in the point cloud, whether that's another level, a plenum, top of roof, etc. Much like we discussed with AutoCAD and the Z-axis, setting the point cloud to accurately line up with a vertical coordinate system is important for easily relating height data in your model. So once you're done, start adjusting your view range and view depths in your plan views to add wall, door, and window families in the places indicated by the point cloud. Now, fortunately, Revit does some heavy lifting for us while we start creating the plans, which leads me to the next slide. So vertical information. As with AutoCAD, this is where there's a huge advantage in having a complete point cloud for modeling. Drawing sections and adjusting section depth is crucial to viewing point clouds effectively when adjusting window heights, door heights, creating roofs, etc. And as with anything, you have to practice patience when you're working on these things, especially for the first time. As everyone knows, roofs are incredibly tough to model, but even more so when you want to make sure that you're matching them as accurately as possible to the point cloud. There's just so many little parameters that you have to tweak to get it just so. All right, so some notes on the BIM process and as-built plans. BIM as-built and final models look beautiful. They're interactive, but there are many more advantages to having a BIM as-built than just the final presentation. So the as-built BIM model can be viewed in multiple phases, so you can easily switch between existing as-built, demo, proposed, and alternate proposed phases. Moving from the design phase to the construction documents phase of a project is far more efficient, mostly for the reasons listed above. Having an as-built BIM model can make it easier to understand a project that you haven't visited yourself, since you can cut sections, view interior spaces, and review the roof massing all in 3D. Some say Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to the owner or to planning departments. Okay, to sum up this fourth and final chapter of this presentation, a summary on creating an as-built set from the 3D laser scanners. So drafting from sketches into CAD is a pretty straightforward process. It takes time to become efficient, but you'll just be entering measurements into CAD straight from your sketch sheets. Modeling into Revit from sketches can be done, of course, but you may find during the modeling that you'll need to ignore certain measurements in lieu of letting the powerful software just build the model properly. Drafting from a point cloud on both CAD and Revit means that you'll be importing the point cloud itself directly into the software and essentially tracing or placing components right on top of the cloud to create your set of plans. And with that, I am done. Thank you, everyone. And back to you, Cameron, to wrap things up.
Yes. Thank you, Greg. That does conclude the presentation. I did want to ask one last question. I see some questions that may pertain to you, Greg, in the chat. So we'll get to those in the QA portion. But real quick, I had a question. So, share your answers in the chat here, but approximately how long would it take your team to measure and draft a 1,500 square foot single family residence? Let's say maybe a floor plan, a roof plan, and elevations are included in that. Feel
While
free to
everyone's
add your
answering,
answers. Yeah.
Sorry
Yeah.
to interrupt. Just to remind everyone to fill out the attendance form. There's a link in the chat. I think that might be the old QR code.
Yeah.
So
This might be the old QR code. So if you can avoid it, don't use that. But Christine has punched the link in the chat a few times throughout. So please use that if you can. And
PPM is also raffling off the Lego architecture series. So you must fill out that attendance form in order to have your name in for the drawing for the Lego.
Yes, and Amber will do that offline. And I think Amber, correct me if I'm wrong, but maybe be in touch sometime probably by the end of next week with that winner.
That is correct. Yes.
Cool. Well, I see some answers to my previous question. I see 3 to 4 days, 40 to 56 hours, 20 to 30 hours. So some variation amongst the answers. So thank you both, or thank you all of you for chiming in there. Let's see. I think we are on to the Q&A, but Greg, as I mentioned, I think there were a couple of questions up here that may pertain to you. First one being from Richard, how accurate is the LiDAR? Do you cross-check with the laser?
Yeah, well, the nice thing about the LiDAR is it's basically about as accurate as any handheld laser that you can use. So the need for cross-check kind of depends on what you're seeing in your point cloud data. So one thing that we do for almost every project that we do the mobile scanning on is we still do, Cam actually talked about it in his presentation about the building perimeter. So we still measure those to just make sure that our overall extents are good. And that can help us identify whether or not there's any drift in that data. But honestly, 99 times out of 100, those perimeters that we measure are in line with what the laser scanners produce. And then the terrestrial laser scanners, those are far more accurate than any handheld laser. You don't really need to worry as much about the drift in using those scanners because it's not using that mobile algorithm to place the data. So I hope that answers your question, Rich.
And then I have another question from looks like Denise. Price difference between terrestrial and mobile. You get this a lot, Greg.
Yeah, I mean, honestly, that sort of depends on the size of the project. It's about, if it's going to take us a day to do it terrestrially, even though we might get it done in less time with the mobile, we still have to be out there for a day. So that kind of comes out in the wash. But on larger projects, there is definitely a price increase just for the amount of time required in the field to do it the terrestrial way. But usually if we're out there using that terrestrial scanner, that means that some pretty serious accuracy is required and that we're looking for a high degree of kind of interactivity between all of the disciplines in a Revit model.
Yes, cool. I do see one other question, and I think we've got maybe a couple more minutes, Christine, for any other additional questions. But I see another one here from Eric. Do you have any recommendations for as-built in congested above ceiling spaces?
Yeah, so and I see Eric's got a couple questions there. I'll see if I can hit both of them. So regarding the above ceiling, doing that manually, doing that the old school way is very, very hard. You have to take so many different measurements, especially if you can't get every ceiling tile down. So that's where laser scanning is absolutely crucial in my opinion. If you need just a few pieces of information like a deck height or a beam height, you can do it the traditional way. But if you really need information on the MEP systems and you really need to have those drawn out, then laser scanning was pretty much developed for that. I would also recommend, I think, the mobile scanning for that. Terrestrial scanning can be pretty time consuming because you have to set up so many different angles to get around it. But the mobile scanning allows you to get around all of those occlusions and pick up more of the systems. The only downside is if you have MEP items that you're looking to track that are, say, less than 3 inches in diameter, you're going to lose a lot of detail on there in the mobile cloud. And then Eric's other question, when you are snapping BIM objects to a cloud of points, what points do you try to pick from the densest part of the cloud line? And line is in quotes. So that's a great question, Eric. And that's something that we deal with on our end in the modeling a lot. It's kind of where best to put the lines. The first thing I'll tell you is don't try to snap. You're going to be tempted to try to snap to individual points. But I would turn all of the snapping off that you can and just look for the best fit of the line on that point cloud line. And that's going to really help you kind of, you can use the nudge tool, the arrows to kind of get things just right into place over your cloud. And that's where we've had the best success.
And I do see one last question from Richard. How do you charge for an as-built? I can explain that pretty quickly here. There's a handful of criteria. So property type is a big one, single family versus all the different commercial types. We charge kind of different price per square foot for that. But also shape, complexity, location, all can be factors as well. Any other questions? Christine, how are we on time?
We're just at noon, but there was one question that came actually directly to me from Winston. Do these devices require an IT budget? Leica is $60,000.
Yes. So that is one of the things that when you're purchasing from these folks, they will, they'll give you the ticket price for the device. They'll tell you everything is really easy. They'll do a demo and show you the scan with a few setups or with the mobile in a small space. And it looks easy and it seems like it's awesome. But they don't tell you immediately right about all the software costs. They don't tell you about all the software options on top of the primary software that you need. And then you absolutely need a very high performance computers to be able to handle all of this data. You need to be able to store what is some really heavy data. We see point clouds anywhere from a few hundred megs up to a few hundred gigabytes. I think the biggest point cloud we've ever seen was almost a terabyte for one single project. So you do have to look at having a lot of storage if you're working on bigger projects or a lot of projects. So there is a bit of a kind of cascading cost implication after you get the device. So that is definitely something worth, if you are talking to Leica, definitely grill them on that. Say, okay, what kind of computer do I need? What kind of, IT support do I need? And they should be able to help answer those questions for you.
Yeah, thank you, Greg. I also
Okay.
have this slide here that has my information there. So any other questions, feel free to reach out to me. I'm available for anything. Look forward to hearing from you. Thank you, Christine, for having
Thank
us.
you guys. Thank you so much. Great program. Just a
And we'll
couple
be
of
in-
announcements before everybody jumps off. Those of you who are in need of some last minute learning units, the AIA California has a credit cram session coming up starting next week. I think it's about 4 days for next week and the following week. They're doing several programs, so you can check out AIA California or subscribe to our email, and you can learn about that as well. And that's about it. Thank you, Cameron and Greg and Amber with EPM for arranging everything, and hope everybody has a great day. Thank you.
Yeah, thank you,
Thanks,
guys.
everybody.
Thank you, Christine. Thank you, Diana.
Thank you very much.